So my name's Darragh. I'm going to give a quick talk on how HP are managing syncing with upstream and how we built a tool called Git-upstream to help us automate our workflow. So quick summary on who I am. I've been working for HP for about 10 years, and most of that time has been in the CI, build, release kind of area, trying to make other people around me more efficient, although I'm sure some of them who are in the room will actually say I don't help them that much. I do help out with a few projects upstream, mostly in JJB and Python Jenkins, and of course Git-upstream, since I'm talking about it. You can find me in the OpenStack infra channel mostly on IRC, and you can check out some of my repos on GitHub. Mostly around Vagrant plugins is the recent work I've been doing. So what's this talk actually about? If you're directly consuming OpenStack from the Git repos and you're looking to contribute back and you're in a company and you're trying to manage that for your team, this is kind of what that's about. This is all really about managing the local backports, trying to handle each time we roll forward to automate dropping or applying the fixes that we had before, and also encouraging our upstream of those local fixes as much as possible. So we try to avoid going out to the side too much, and we try to kind of keep coming back in to stay in sync with upstream as much as possible and get everything we have up there. So this is the workflow used by HP Helion, which just released. If you're consuming distribution packages, you might be able to use this, but you'll probably have to put something on top of it. So why do we need to align local patches with upstream? And actually, why do we even have local patches? And why do we need some special tool to help us do this? So I'll take the tool first. Why we want to do this with a tool? Well, we're syncing daily. And in fact, we're trying to get to the point where we could be syncing every time a change lands upstream in every single project we're tracking. If you're to do that manually, you're talking about between 5 to 30 minutes, and that's when you get it down really, really well. At the start, the guys who were doing it manually took about 4 to 8 hours to kind of work out that actually they'd done it right. You can't do that daily. If you follow XKCD at all, you'll love this little graphic that tells you just how much time you start to save if you can actually reduce the amount of time these things take when you're doing them daily. And at the sort of rate we're doing it, it's probably worth spending 90 engineer days a year just making this faster. You know, trying to get it below 1 minute, that's how much time it's worth to the rest of the organization. Currently, it just works about 90%. Not sure if it's 98% or 91%. I haven't worked out how to actually get that information, but we're pretty certain that there's not enough people screaming that it's less than 90%. So the second question, why are we carrying local patches? Because this question comes up occasionally. The ideal is you contribute upstream and you just consume when it's landed. And that's great, but there's a few assumptions in that ideal. That is, all the bugs that we encounter can be easily debugged in a virtual environment and fixed there. Acceptance upstream is really, really quick. You never have to wait 9 to 18 months for a patch to actually get accepted. Has happened. And there's absolutely zero risk of any bugs coming back down when you could take the latest. Because guess what? You don't just get your patch, you get the other 50 patches that landed in the last day as well. And there's the other assumption that it's okay for you to be broken locally. That's no good. You know, if you've got 50 engineers and there's one change has landed come from upstream and it breaks it for everybody, you need to get that patch to all the other 49 people that you're working with. You need to get it to your QA people, and you need to track that you've actually applied that and get it upstream. So it's not good enough to wait another day or two blocking people from testing new features just to wait for the fix to land, and that's if it gets in within a couple of days. I think I heard the average is the minimum average is about 4 days. So this is probably the more likely scenario. That is, you do your stress testing, you didn't find an issue, great, just send it on out to your QA people. Probably you found a bug somewhere, because otherwise we wouldn't be submitting any bug fixes upstream. You want to apply that locally and also submit upstream. But when you get the next upstream, you want it to be really quick to actually reapply any fixes that haven't yet landed upstream. And that's where you want the automation. So what type of fixes are we talking about? I'm sure most people have come across these. You might have packaging fixes if you want to build RPMs, debs. Compatibility hacks, if for some reason you can't take the latest libraries that the upstream depends on. Backports, because they're just not going to backport some functionality that is handy right now to a previous release. And you got dumb fixes. Yeah, we break stuff just because it needs to be done in our environment. And there's scale testing. And I don't just mean scale at 100 nodes. I mean scale at taking a week, leaving a system running for a week and seeing what happens. We can't do that upstream. They just don't have enough machines possibly in the world for every single change to be left soaking on a system for a week. So basically anything that needs to be used in an environment besides your personal DevStack area, you have to track it, you have to handle it locally. And this is where our tool fits in. Those three little boxes where we have like handling what was applied locally last time, working out where we want to get from upstream and what changes still actually apply to that upstream and what changes have actually already landed. And we want that to be automated. Because like I said, if we're doing that for 25 projects every single day, we don't want people spending even 5 minutes on each project trying to work that out. Is there any benefits upstream if we carry local fixes? You know, it's kind of the reverse scenario. Everybody's saying, oh, get it upstream. Sometimes it's useful that you can actually verify with your QA team that you got the fix right. You know, would be great if you got the fix up there and it came back down, you consumed it, and you kind of go like, oops, that doesn't work. You could also might want to run some debug patches on live systems, and sometimes you're gonna, what works for a DevStack environment with a few nodes might not be so good with 100 odd spewing the same debug messages. So you need to possibly apply those, roll them out, and see what happens before you can actually say, this is good, or actually we need to tune that back a tiny bit. And finally, you actually want to allow some time for people to give feedback on whether your fix is actually a good idea while you get on and let everybody else in your organization get on with their day-to-day work. So there are the links to how you're going to clone it. If you want to install it from PyPy, it's just pip install Git-upstream, and there is an IRC channel. So the basic description kind of up on PyPy is missing one little bit of a hint. This is really tailored to working with Gerrit. So at the moment, it could be work with any Git project, but it's focused on using the Gerrit workflow from OpenStack. So that's why it's mainly targeted at OpenStack for the moment. So how do we actually go about staying in sync? It's kind of two phases. Consume, pull down all the changes from upstream, push them to some reference space that's in your local, I hate to say fork, but it is technically a fork locally. There is an example job actually in the repo, so you can actually go and look at that and see how we generally do it. I think it's a bit different in our environment, but that script does work. And then you have the next step, which is the importing and realigning, and that's getting git-upstream import, which is the entire command line ideally, for it to work out what patches that you're carrying and apply them again. So it tends to be a little bit more. But this is the basics. You just run git-upstream import, but there's options to deal with just about everything. There is lots and lots of options, but I prefer defaults that usually work. So if you name things certain ways, it should just work, and you should not have to worry about any of the extra options. And the idea is that once it's complete, you will upload the final result to your Gerrit for review, to go through your CI system, to make sure that for some reason these patches actually still also work. By default, it's really quiet. It doesn't actually output a whole lot. It just tells you, done a few steps, I've succeeded. If you want to spam your console and look confused, you can turn on a massive verbose mode. The verbose actually includes pretty much every Git command that's running behind the scenes. So this isn't manipulating the Git DB somehow magically. It's all Git commands. It's just using plumbing commands behind the scenes. Ideally, if you're going to report a bug, I'd prefer if you try and at least do the debug to a log file. So you don't have to spam your console, but I have some idea what happened. And there are additional commands, but I'm only going to focus on the import one. There's 2 helper commands, a drop and a supersede, to deal with the odd situations that there's no way you can automatically determine that someone has a patch up there that now completely supersedes yours. So down to the actual, that's the command line, down to the actual bones of what are we doing that is so special that we decided we needed to write a tool to manage this. If you look at how most projects track working with forks or people that need to diverge, you basically have 2 approaches. You got merge requests, which work really well for the Linux community, and you got patches, which has been proved really well for OpenStack, for review, for everybody to look at. And we kind of worked out that the odds are if you get a single line change that needs to be made to the patch that you uploaded to the community for review compared to what you applied locally, you're pretty much guaranteed to get a conflict when you merge. And there's just no way we can automate that. It is just pretty much impossible. So whatever we were going to do, we had to use a patch queue type system, and that's essentially what it does. There's a few other tools in this area, so even if you're not interested in Git-upstream, I would suggest you go and look at them. Guilt is quilt in Git for managing patch series files. There's a couple of topic branch tools that's called stacked git, st-git, and topic git, top git. And there's another one for the packaging. If you're using Debian packages, that'll work really well for managing the patch series called git-dpm. Unfortunately, when you're reaching down that low level into the underlines of what you need to do, manipulate a Git repository, it just doesn't work well mixing and matching some of these tools. You can't easily reach in, use one, combine it with necessarily what you want to do in your workflow, but you can make it so they can work on top of you or below you, just as long as you're not trying to interface directly with them. And yeah, obligatory XKCD. Yeah, we created it as a standard. So this is kind of a summary of the requirements we worked out. We essentially wanted the exact same workflows upstream. We did not want to review diffs of diffs. That's just horrible. And we also wanted to automate the discard of patches landed upstream. And the really important one, we wanted to ensure that we encouraged ourselves to stay upstreaming all the changes. Because yes, forks are ugly. I hate them. And I wrote this tool. So what do we really do behind the scenes? We kind of worked out that Git already understands how to manage patches. So we just needed to work out how we got from the current to the desired without messing up anybody. And this is the kind of the hidden elephant in the room if you've ever worked with Git and rebase. If someone rebases a branch you're based off on, it pretty much makes it impossible. You're going to make every developer downstream from you, and that means everybody else you're working with hate you. What Git does is, though, you can kind of cheat. You can make any commit that you're going to make identical in the tree to another commit. So we can basically make a merge commit on top of our current that says, make it look like desired, and merge that history in. Thanks very much. And everybody else is just rebase their local patch on top of it, and it just works. So usage in HP Helion, we have a little bit of a drift. We do keep an eye on this. Those patches will appear upstream from all those projects. There's a whole host of them. We're trying to keep track of these. I think most of them are just backports of bug fixes that have come from upstream. I do need some help. Please help with Git-upstream. There is some difficulties in it. It's got some warts. And the final, there is a roadmap. So if you're interested in it, there is more stuff to be implemented. The project is in OpenStack. It's available to use. You can go clone it. You can check out whether there's anything to be reviewed. I think it's empty. And I said, please help. OK, and that's it. So if you're interested in finding out more, I'll be outside for the next few minutes. And you can check me out on IRC. There's a dedicated room to it. Wow, only 20.